So far, we've studied in more detail 3 types of energy storage modes. So kinetic energies, the energy of motion, and gravitational and elastic potential energy. And we've talked about when that energy is transferred from one type to another, we don't get any energy gained or lost in those processes. In fact, the conservation of energy is true for all types of energy. So whether whatever process is going on, energy is always conserved. So just to highlight that again, a statement of the conservation of energy is that in any process, the total energy is neither increased nor decreased. And energy may be transferred from one storage mode to another. So for example, kinetic energy to potential energy, or transferred from one object to another. So the kinetic energy of object 1 might be transferred to object 2 during a collision. Now this statement is an empirical result. It rests on experimental observation, and it's been found to be true for all experimental observations that have so far been tested. What it implies is that the total amount of energy in the universe hasn't actually changed since the beginning of the universe, so since the Big Bang. And it's really important here that we note that it's the energy in the whole universe which is neither increased nor decreased. And I'll explain what I mean by that. So it's the total amount of energy is constant. So what we need to consider when we're looking at problems that we look at in this course, that we consider a subset of the universe. We consider a system of objects, and those objects can, say 1, 2, 3, 4, they could actually transfer energy between them by whatever processes. So we could have kinetic energy being transferred to a potential energy storage mode, and so on. And so if we've got a closed system like we have here, there's no energy transfer in and out of that system. Then within that system, yes, the total amount of energy is constant. But it turns out that there are 3 ways of transferring energy into a system and out of a system. You can change the total amount of energy in a system by working. Now, work in the physics context is a very specific term. It means that you have energy transferred by forces that cause a displacement. Now, you can think of this, an example of this is, say, if you push an object, you will, so if there aren't any other forces acting on it, so the net force, it will accelerate in that direction, and so it will gain, in that case, kinetic energy. You can also push an object against a field and it will gain potential energy. So it's work being transferred to that system as long as those forces are causing a displacement of the object. We also have radiation. So that's energy transferred due to electromagnetic radiation. So it could be anything. It could be light in the visible part of the spectrum, or in the infrared, or microwaves, say. So energy can be transferred in and out of the system due to radiation. And the third is heat, which we give the symbol Q, and that's energy transferred due to a temperature difference. So if you have a hot object sitting next to a cold object, there will be a transfer of energy from the higher temperature object, the hotter object, to the cooler object. And we're going to look at those processes in a lot more detail in the next part of the unit. So we've defined this system of objects, and the rest of the universe is called the surroundings. So that's all objects that are not in that system. And this brings us to what is known as the first law of thermodynamics. I'll just write that down there, the thermodynamics, that the initial energy of a system plus any work transferred to it, or minus work transferred from it, caused by work processes, so forces that cause displacement, plus radiation, either in or negatively out of the system, plus energy transferred by heating. simply equals the final energy of the system. And these energies are all the kinetic and potential energies of the system. And just to point out again that the W, R and Q, they could be positive if energy is being transferred to the system, or they could be negative if energy is being transferred from that system.